Hello, I'm Edgar Aponte, and today I'll be talking about rubber bands and how excellent polymers they are. First, I'm going to be talking about the material composition and the polymer science behind them. Since rubber bands are made out of thermoplastic elastomers or silicon rubber, uh, it gives the, the ability of rubber and the properties of plastics, which are very useful when trying to build something. For example, as you can see here, here's the 3D illustration of the elastomers. In the far here, you can see that the bonds are aromatic rings, which are combined together. And in the middle here, if you look closely, when you see the oxygen atoms are hydrogen bonded to the hydrogen next to the next to the carbon atoms here. These make them more durable, and the aromatic rings uh, give them more stability compared to just a um, normal cyclic compound. The properties they have, thanks to their molecular formation, is that they're viscoelastic. Like I said before, that they exhibit the viscous flow-like and the elastic behavior uh, of plastics, and they also have, since of the chains, like shown in the illustration before, uh, they have a better time recovering after being deformed. Uh, so using the same point as before, the rubber bands have memory shape. So after their manufacture, they will usually keep the shape they were formed as. And after being stretched, they will try to go back to their original shape. Um, and also due to the entropy of the elasticity, the chains align together to become stronger, as you've seen before here with the oxygen, that they have such better bonding, not just to one of the molecules, but molecules with each molecule. 'Cause here on this side is one molecule, and this other side is one molecule, and they're bonded with the hydrogen bonding to other molecules, which gives them more stability. Um, they also have high elongation at break, which means they can stretch significantly before snapping. So if I stretch this for much longer and farther, it will break. But it also has the low young modulus, which means it's easily deformable. As you can see, I can use it with my hands. Which and it has a 0.01 to 0.1 gigapascals, which means it's good for damping vibrations. But since it's so easily deformable, it's not good for rigidity, which steel, compared to rubber, has 200 gigapascal of young modulus, which is significant. And then for hysteresis, uh, it gives away energy when it expands or has any type of change, which helps it, with the viscoelasticity. For the manufacturing of rubber bands, they're usually used in a mold. They melt the TPE, the material for rubber bands, and then inject them into molds. And after that, they treat them with heat, so the outside layer is stronger than the inside layer, which gives them better uh, better attributes and properties for its stability. And then since it's a polymer, it it has different properties compared to just metals or organic material. Uh, but the thing is, it also has its failures, which this rubber band, compared to this rubber band, was put under the sun for a day. And as you can see, this one kept its color, and then this one lost its color and it shrunk. And if the camera catches it, it has started to deteriorate because of the UV rays. Another thing is that if I start overstretching it, uh, the material will start to deteriorate as well, and it will not go back to its original shape as easily because of the bonds that are being broken. Another thing to watch out for is chemical exposure. Some oils and solvents will break the bonds. One example of that is limonene, which is a citrusy oil, which can be found in lemons and lime, which is what gives it that citrus aroma. It will break those bonds very easily. And, it's something to keep in mind when using rubber polymers for anything like that. The information I got it from was from this book by Ferry J. Uh, D. And it was talking about the viscoelasticity of polymers. I mainly used chapter 1 and 5 for the beginning parts, and then chapter 11 to understand more of the downsides of using uh, this type of polymer, the TPE polymers. And then I use um, this John J.A. Johnson to see the the characteristics the characteristics of the polymers and the structure that each one has. Um, that should be all. Thank you for watching my video, and I hope you have a great day.